So in this video we're going to look at solving equations that have two radicals in them. So here we have an equation that has two radicals. So I'm going to go ahead and rewrite the original equation. And the basic idea here is that you're going to have to square both sides twice. So the thing that you want to do is to isolate one of the two radicals, and it doesn't matter which one you isolate, but it must be completely isolated. So for example, I could add this radical to both sides. It's being subtracted, so I do the opposite of that. I go ahead and add it to both sides. So I wind up with 1 plus the square root of x plus 31 on the right hand side. And when I do that, that's going to leave me with just the square root of 3x plus 34 on the left hand side. And at this point, this radical has been completely isolated. There's nothing being multiplied on the front of it. Nothing is being added or subtracted from it. It's completely isolated. So if we square it, the squaring will cancel the square root, and the stuff under the radical sign will drop out. But whatever we do to one side, we have to do to the other. And unfortunately, I have to square all of this side. And what we want to remember when we square something, we have a plus b squared. That's going to equal a plus b times a plus b. So if you can kind of think about the pattern that you get an a times a, you get an a squared. So in this case, the 1 here is in my a position, and the square root is in my b position. So you wind up getting 1 times 1 is 1 squared, or 1. You get plus, you get a times b, plus b times a, or a times b again, plus you get b times b is b squared. So you get the a times b twice. So I'm going to get 1 times the square root, and it's got a plus e. I'm going to get 1 times the square root, but I'm going to get it twice. So I'm going to get 2 times the square root of x plus 31, because I get 1 times this. I get the a times b 2 times, so there's my 2 saying I got it twice. Plus, and then you get plus because it's going to be plus times plus is plus. And then I'm going to get b squared. So I'm going to get the square root, which is in the b position. I'm going to get the square root of x plus 31. And it's going to be squared. And that's what I get on the right hand side. And then things will simplify a little bit. I could subtract this 1 from both sides, because ultimately what I'm going to need to do is isolate this other square root and square things again. So I'm going to subtract this 1 from both sides, which will give me 3x plus 33. I've got the 2 times the square root of x plus 31 from right here. And when I square this square root here, it's going to cancel the square roots. I'm going to get plus the x plus 31 that's under the radical sign. Again, I want to isolate this square root now so I can square him. In the first step, I isolated this guy. I squared him. I got the stuff out. Now I need to isolate this one, square it to get the stuff out. So I'm going to need to subtract x from both sides, which is going to leave me with 2x on the left hand side, subtracting this x from both sides, and then subtract 31 from both sides. So I'm going to get 33 minus 31 is 2, and that leaves me with 2 times the square root of x plus 31. And I've almost got the square root isolated, but I'm going to divide by 2 on both sides. And this 2 is going to go evenly into each of those 2's, so I'm going to get x plus 1. I could, what I can recognize here is that I could factor that 2 is a common factor. I can factor that 2 off. It leaves me with 2 times x plus 1. And then dividing 2 into this 2 is going to cancel and leave me with x plus 1. And that's going to leave me with the square root of x plus 31 isolated. So now I'm ready to square both sides. I'm going to go ahead and go forward a slide just so I have more writing space. So we were in the position where we had x plus 1 equaling the square root of x plus 31. So we have this radical isolated. We're going to square him now. And if we square him, then the squaring cancels the square root and drops the x plus 31 out. But whatever we do on one side, we need to do on the other. So I need to do x plus 1 times x plus 1 is going to be x squared plus x times 1 is x, but I'm going to get that 2 times, so it's going to be plus 2x's plus 1 squared is 1. And now it looks like I have a quadratic, so I'm going to get it equal to 0 to see if I can factor. So I'm going to get x squared, subtract x from both sides, it leaves me with plus x. Subtract 31 from both sides, leaves me with minus 30. It's got a leading coefficient of 1 on this quadratic, so I'm going to try to guess its factorization as my first step. If I can't factor it nicely, then I have other options, right? If I can't factor it and use the zero product property, I can use the quadratic equation. I can use completing the square. Both of those are techniques that would work for solving a quadratic, but in this case it does factor pretty nicely. X plus 6, x minus 5. And now I can use the zero product property, so I get x plus 6 equals 0, or x minus 5 equals 0. So either x is 5 or x is, subtracting 6 from both sides, negative 6, but you have to check to make sure they work. So if we check, x equals negative 6. Everywhere where we see an x, we're going to plug in the negative 6, so I get the square root of 3 times negative 6 plus the 34 minus the negative 6 goes in here plus the 31. And if negative 6 works, this side will need to simplify to be positive 1. So here I have negative 18 plus 34 minus negative 6 plus 31 is 25. And then what do we get from this? We get 16. We get square root of 16 minus the square root of 25 is 5. And the square root of 16 is 4 minus 5. And what we see is we get negative 1 equals 1, which is false. So negative 6 is not a solution. It's extraneous, so we toss it. And then we need to check the other guy. Check x equal 5. So plugging the 5 in everywhere we see an x, we get square root of 3 times 5 plus 34. Better write that 4 better. I'll use it like it's a 9 or something. Square root of, replace that x with a 5. We get 5 plus 31, and it needs to equal 1 if it works. So we get 5 times 3 is 15, plus 34 is the square root of 49, minus the square root of 5 plus 31 is 36. And that's going to be 7 minus 6, which does equal 1. So we get a true statement or an identity here, whereas up here we got a false statement all the way through where the two sides weren't equal. So it turns out that the solution set is just the set that contains the real number 5.